Welcome, data professionals. Today, we are exploring Snowflake Cortex Analyst, a game-changing feature for translating natural language into perfectly accurate SQL queries. Let's get started. Hello everyone, and welcome to this deep dive into Snowflake Cortex Analyst. Imagine empowering your business users to ask complex questions in plain English and instantly receive accurate answers directly from your structured data. That is exactly what Cortex Analyst delivers. It is a fully managed, LLM-powered agentic AI system designed to translate natural language into optimized SQL queries. Why is this revolutionary? Because building a production-grade conversational analytics solution is typically a daunting task that requires balancing accuracy, latency, and expensive GPU costs. Cortex Analyst abstracts all of that complexity away. Furthermore, it is exposed via a highly convenient REST API, meaning your development teams can seamlessly integrate this capability directly into the platforms your business teams already use, like Microsoft Teams, Slack, or custom Streamlit applications. Let us take a look at the high-level architecture in this flowchart. On the left, the business user submits a question in natural language. This request securely hits the Cortex Analyst REST API. The API passes the context and intent to the state-of-the-art LLMs hosted natively within Snowflake Cortex. The LLM then generates a precise SQL query, which is pushed down into your highly scalable Snowflake data warehouse for execution. Finally, the accurate, data-backed answers are returned to the user in seconds. The entire flow is secure and fully managed. You might be wondering, why use Cortex Analyst instead of a generic public AI chatbot? Generic AI solutions almost always struggle with text-to-SQL conversions because a raw database schema completely lacks critical business context. A generic model doesn't know your specific definition of net revenue or how to handle complex proprietary metrics. Additionally, using public AI tools introduces massive data privacy risks. With Cortex Analyst, your data stays entirely within Snowflake's governance boundary. It is powered by state-of-the-art models from Mistral and Meta hosted securely inside Snowflake Cortex. Snowflake guarantees that your customer data is never used to train or fine-tune models for other customers. Most importantly, Cortex Analyst seamlessly integrates with Snowflake's role-based access control, ensuring that the generated SQL queries can only access data the user is explicitly authorized to see. This diagram contrasts the generic AI approach with the Cortex Analyst approach. When a user query enters a generic LLM, it tries to map directly to a raw database schema. This lack of business context inevitably leads to hallucinations and broken SQL. Conversely, the Cortex Analyst path operates strictly within the Snowflake secure boundary. It leverages semantic business context to understand the true intent of the question, resulting in RBAC-governed accurate SQL. This ensures both high precision and enterprise-grade security for every single request. To overcome the limitations of generic AI, Cortex Analyst requires a brain that understands your unique business logic. This is achieved through semantic models and semantic views. A semantic model acts as the ultimate bridge between the vocabulary your business users speak and the highly technical definitions of your database. Captured in a lightweight YAML file or as a native schema-level semantic view, it defines your business reality. You explicitly define logical tables for entities like customers or orders. You define dimensions for slicing data, facts for raw quantitative amounts, and strict metrics for calculating business KPIs like total revenue. You also define relationships, which give the LLM predefined join paths. By providing this rich metadata, descriptions, and exact aggregation formulas, you guarantee that the LLM generates mathematically perfect SQL. Let's explore the anatomy of a semantic model in this structural diagram. At the top level, the semantic model serves as the container. It breaks down into logical tables, which represent your core business entities. Within these tables, you meticulously define dimensions for categorization, facts for raw data, and metrics for complex KPI aggregations. Alongside the tables, you explicitly define relationships. This relationship mapping is crucial because it instructs the AI exactly how to join tables together, preventing the common LLM mistake of generating massive, incorrect Cartesian products. Even with an excellent semantic model, certain executive-level KPIs require absolute, undeniable accuracy. For this, we use the Verified Query Repository, or VQR. The VQR is a curated collection of human-approved business questions and their exact corresponding SQL queries, embedded directly within your semantic model. When a user asks a question, Cortex Analyst performs a similarity search. If the question closely matches an entry in the VQR, the system bypasses guessing and leverages that verified SQL template directly to answer the question. This completely eliminates hallucination risk for your most critical reports. Furthermore, the VQR powers an onboarding questions feature. By setting the use as onboarding question flag to true in your YAML file, you can surface these verified questions in your chat interface, guiding brand new users on exactly what types of questions the system is trained to answer. This decision flow illustrates how the verified query repository protects your application. When a user question arrives, the system first evaluates, does this match the VQR? If there is high semantic similarity, the flow routes up, retrieving the verified, human-approved SQL template. If it is a novel, ad hoc question, the flow routes down, falling back to the standard semantic model to generate the SQL dynamically. Both paths converge to execute the query safely, ensuring your users always receive a highly accurate result, balancing strict governance with ad hoc flexibility. A major hurdle in text-to-SQL generation is handling exact string literals in where clauses. For example, if a user types "show me sales for iced tea," but the database actually stores the product name as iced tea, a standard SQL generation will fail to find any records. To solve this, you can integrate Cortex Analyst with Cortex Search services. Before writing the SQL, Cortex Analyst performs a low-latency, fuzzy semantic search over the underlying data to find the exact, correct literal values. By retrieving these sample values and presenting them to the LLM as context, the system knows to write the SQL query using iced tea, successfully matching the database record. You can easily configure this directly in the Cortex Analyst UI, which automatically helps you select high cardinality text columns to build this intelligent search integration. This sequence diagram details the incredibly smart literal resolution process. The user requests sales for iced tea. Instead of blindly writing SQL, Cortex Analyst pauses and queries the integrated Cortex Search service. The search service performs a fuzzy semantic match and returns the exact database literal, iced tea. Armed with this perfect context, Cortex Analyst proceeds to generate the SQL query with the correct where clause, executing it, and returning the accurate sales results to the user. This eliminates empty result sets caused by simple typos. True data analysis is never just a single question. It's a multi-turn conversation where users drill down into the insights. Cortex Analyst natively supports this dynamic exploration. When a user asks a follow-up question like, "What about North America?" they expect the AI to remember what they were previously talking about. Behind the scenes, Cortex Analyst utilizes a specialized LLM summarization agent positioned at the very beginning of the workflow. Your application passes an array of the conversation history to the REST API. The summarization agent analyzes this history and intelligently rewrites the fragmented follow-up into a fully resolved, self-contained question such as, "What is the revenue for North America?" This rewritten question is then passed to the Cortex to SQL engine. This brilliant agentic architecture preserves processing speed and maintains extreme accuracy without multitasking. Let's track a multi-turn conversation visually. The user asks Q1 about revenue in Asia and receives answer 1. They then ask a vague follow-up, Q2, what about NA? The REST API passes Q2 along with the conversation history into the summarization agent. This agent merges the context, explicitly rewriting the prompt into a resolved question, revenue in NA. By the time the prompt reaches the Cortex to SQL engine, it is a perfect, standalone request. This guarantees the SQL generated for A2 is flawlessly targeted at the North American region. Let's put this into a powerful real-world use case. Imagine a global VP of sales who needs to investigate a sudden quarterly revenue drop. Traditionally, they would submit a BI ticket to the data engineering team and wait days for a custom dashboard. Instead, your engineering team embeds Cortex Analyst directly into Microsoft Teams using the REST API. The VP simply opens Teams and types, "What is the month-over-month revenue growth for 2021 in Asia?" Instantly, Cortex Analyst uses the semantic model to calculate the exact revenue metric and returns a precise answer. The VP then uses multi-turn conversation, asking, "What about North America?" The system maintains context, rewrites the query, and instantly provides the North American data. What used to take days of back and forth now takes literal seconds, driving a true data-driven, self-service culture. This architecture diagram summarizes our executive use case. The interaction begins in the collaboration platform, specifically the Microsoft Teams chatbot. The natural language questions securely traverse into the Snowflake platform via the Cortex Analyst REST API. Inside Snowflake, the intelligent engine consults the semantic model for business rules and checks the verified query repository for exact matches. Once the SQL is formulated, it is pushed down into the virtual warehouse for high-performance execution. The final data payload securely returns to the team's interface, completing the self-service analytics loop. Finally, as senior architects, we must manage costs and observability. Cortex Analyst incurs compute costs based strictly on the number of tokens processed during the orchestration and SQL generation phases. It is important to note that during multi-turn conversations, LLMs do not store state. Therefore, the full conversation history is processed with each new question, meaning token consumption slightly increases with each conversational round. To maintain total visibility, administrators can query the Cortex function's usage history view to track credit consumption. Furthermore, Cortex Analyst logs all user requests to a dedicated event table. You should actively monitor these event tables to see what questions users are asking, allowing you to continuously refine your semantic model and add popular questions to your verified query repository. Thank you for joining me today. I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. This final flowchart highlights the crucial observability loop. User interactions are processed by Cortex Analyst. Simultaneously, the system splits its telemetry. On the top path, detailed event logging flows into an event table capturing the request history. On the bottom path, billing metrics flow into the Cortex function's usage history view. These dual data streams empower the Snowflake administrator. They can use the event logs to refine the semantic model over time and use the usage history to optimize token costs. This continuous improvement cycle ensures your AI applications remain both highly accurate and economically viable.